supply voltage Vs, and as usual we have to give an alpha at some point of the input supply. I consider I am giving my alpha at this particular point, and here I am giving my alpha at this particular, the same alpha I am giving for the negative cycle also. So in the output waveform, we can see the output will be available from this alpha onwards. Then, sorry, this is wrong, right? I should complete it here. And from pi to pi plus alpha, this is called pi plus alpha, and this is alpha. And from pi plus alpha to, once again, 2 pi, there will be output voltage. So the waveforms are not proper, so try to understand it clearly. This is the problem with the online classes for power electronics. We cannot draw everything perfectly. So the output voltage will be something like this. This is alpha, this is pi plus alpha, and this is 2 pi. This is how the output voltage will be available across the load terminal for a full converter, that too for R load, because when during the first half cycle, this T1 and T2 will be in forward biased condition. And when you supply the triggering pulses at omega t is equal to alpha, these two devices will be in on condition, and the circuit gets connected like this. This is a loop for the first half cycle. But so this is a condition for the first half cycle, and which are the thyristors working? T1 and T2 during this condition. That's why we get the positive off cycle output across a loaded terminal with the help of T1 and T2. And at omega t is equal to pi, automatically the current through the thyristors becomes less than holding current, and T1 and T2 will be moved to cutoff region or off condition, and the thyristor pair T3 and T4 will be ready to conduct, and it will be in forward bias condition. And once again, at omega t is equal to pi plus alpha, T3 and T4 will be triggered, and the circuit now it gets connected, because now this is positive. So the circuit gets connected something like this. It gets connected like this. So now also the load is receiving the same positive and negative voltage in this polarity. So sorry that I made a great mistake, but no one has informed me, right? The output should be positive. This is the status of your class and how much you are listening the PPT. Nice. Okay. So from pi plus alpha to 2 pi, the output voltage is once again positive, because it is rectified because of the thyristor pair T3 and T4, and the positive waveform is available here. Means that both the positive half cycle and the negative half cycle is, and the second half cycle is available because of the working condition of T3 and T4. During the first half cycle, T1 and T2 plays a role, and during the second half cycle, T3 and T4 plays. This will be the nature of the output voltage across same pattern, but only thing the magnitude may be little bit different because of that depends on the supply voltage magnitude and the resistor value. But the voltage waveform and current waveform will follow the voltage waveform exactly when the load is R load. That's what we have to understand. So, and if we see the output voltage, I think now we can write the there is no change. The same throughout the operation of the full wave converter. So it is more than enough to take average for the first half cycle because the same thing is going to be repeated. So the limits can be something like this. So the average is going to be taken only for the time period pi, and the waveform is available from alpha to pi. Once again, Vm sine omega t d of omega t. That's all. So this becomes Vm by pi minus cos omega t alpha to pi. So you will get Vm by pi 1 plus cos alpha. In the previous cases, you got Vm by 2 pi 1 plus cos alpha. Now you got Vm by pi 1 plus cos alpha. This is for average output, average DC output voltage. Similarly, the RMS voltage can be written as 1 by pi alpha to pi Vm square sine square omega t d of omega t whole power 1 by 2. This is a limit and the equation for deriving the output RMS voltage of full wave converter. Just a minute. Right, this is the equation, and if you try to manipulate this, you may get an equation. Vm into pi minus alpha by 2 pi sine 2 alpha by 4 pi whole power 1 by 2. Right, please check it. Please check this whether this is correct or not. At least refer the book. Right. So now this is the condition. This is the working condition of a full wave rectifier when it is supplying the R load. When it is supplying the R load, and we have to understand even at least from the average output DC voltage, when you increase alpha, the average DC voltage will be reduced. Right? When alpha increases, the VDC decreases. The reason, the time period where the output voltage is available across the load terminal will be reduced if alpha is increased. For example, alpha is equal to 0, the entire voltage is available across the load terminal as a rectified sine wave. And when you increase alpha is equal to omega alpha is equal to 30, from 0 to 30, and once again from 180 degree to 210, there is no output voltage across the load terminal. So definitely for the same period of 2 pi, the average output voltage is reduced. Similarly, when you further increase alpha to 60 degree or 90 degree, the average output voltage will keep reduced. And this is how we can control the output rectifier, output of the rectifier. We cannot increase the output voltage beyond some certain value. The maximum output, average output voltage can be obtained from the rectifier circuit when alpha is equal to 0. So when you try to control the output voltage will be reduced, not increased. Even though we say it as a controlled one, you can have control on only one side, right? The maximum output voltage will be obtained when alpha is equal to 0, which is almost equal to the working condition of a full bridge diode rectifier, diode based full bridge rectifier without any SCR. And if every component is a diode, it will automatically rectify the sinusoidal supply whenever the zero crossing occurs. So if you do such operation, the average output voltage will be maximum when alpha is equal to 0. So when the alpha is increased, the output voltage is decreased as proportional to the alpha value and proportional to this formula. So, and the output voltage will never become negative at any point of the cycle, since the output is considered as, the load is considered as completely resistive. If the load is having an inductive component, then based on the value of R and L combination and the load angle, the output voltage, the some negative output voltage will appear across the load terminal, even though we say this is rectifier, because of the nature of RL circuit and the working principle of the thyristors, a small negative peak, negative part of the voltage will start to appear if the load is RL in nature. That we have to understand, and that depends on the alpha value and the load angle. We have some three different working conditions, right? In R load, there is no difference in the working principle. When you supply alpha, the thyristor starts to conduct, and when omega is equal to pi, that particular pair will be turned off, and the next set of thyristors will be ready to conduct. And when you apply triggering pulses at omega is equal to pi plus alpha, the next set of thyristors starts to conduct, and it will conduct up to omega is equal to 2 pi. This will be repeated continuously throughout the working condition, of the circuit, and the voltage will never become negative at any point of time. So the voltage can be reduced between some values but it cannot be made negative, right? That you have to understand. And the maximum output voltage is available only when the alpha is equal to 0. That you can understand theoretically from the graphs, or you can understand that from the formula mathematically. When you substitute alpha is equal to 0, you get the maximum voltage, and when you substitute alpha with some other value, your average output voltage will decrease, both average and RMS, right? So that can be understood from this, right? And so this is okay. I think we can stop with this. So next class we will see RL load, and we will proceed with the semi-converters. And with this week, this complete unit will be over, right? Within this 4 class, the rectifier unit will be over. So try to attend the classes without any disturbance. And let me check the